What if a lone object hurtling through the void isn't a rock or a piece of ice? What if it's a test? A cosmic probe sent by an intelligence from another star designed to do one thing: see what we do when we find it. There is something out there, right now. Its name is 3I/Atlas. Discovered in July 2025, it is breaking every rule we have for how interstellar visitors should behave. Its path is too perfect, its timing is too precise, and its light is all wrong. This isn't just another space rock, this is an anomaly. And according to the math, the odds of it being a coincidence are 1 in 20,000. This is the story of the visitor that shouldn't exist. A calculated approach. Interstellar objects are supposed to be chaotic. They scream into our solar system from random steep angles, wild, untamed arrows shot from the dark. Oumuamua in 2017 was like that. Borisov in 2019 was like that. But 3I/Atlas is different. It didn't come from above or below. It arrived almost perfectly in the plane of our solar system, just 5 degrees off the ecliptic, the same flat disk where Earth, Mars, and Jupiter orbit. It's not a wild arrow, it's a calculated entry. Its trajectory isn't random, it's a survey route. First, it made a close pass by Mars. Then it swung by Venus. Its next gravitational handshake is with Jupiter. This isn't a random path through a solar system. This is a planned itinerary. The statistical probability of this happening by pure chance? Astronomers calculate it's 1 in 20,000. Those aren't odds. They're a signature. Hiding in glare. But the precision doesn't stop with its path. The timing is also convenient, suspiciously convenient. 3I/Atlas is scheduled to make its closest approach to the Sun, the moment when any comet would be most active, venting gas and dust and revealing its true nature, at the exact time when Earth will be on the opposite side of the Sun. We will be blinded. The solar glare will completely obscure our view. It will vanish from our telescopes at the most critical moment, only to re-emerge later, already on its way out of the solar system. Think about that. Of all the possible timelines in a year, this object's peak activity coincides perfectly with the few weeks we cannot see it. Is this the ultimate cosmic coincidence? Or is it the hallmark of something designed to observe without being fully observed in return? A glow that doesn't fit. At first glance, 3I/Atlas checks the boxes for a comet. It has a coma, a fuzzy envelope of gas and dust. Spectrometers have detected water ice and carbon dioxide. But when you look closer, the story unravels. It's too bright. The way it reflects sunlight suggests it should be enormous. A mountain may be 20 kilometers across, but other data doesn't support that. Its brightness profile is unusual, almost sharp. It doesn't have the gentle fall-off of reflected light. It's as if the light is coming from within. So what could be causing this anomalous glow? Radioactive decay? Possible, but it would require concentrations of heavy elements that are incredibly rare. Internal heat? Its temperature is too low. There is another possibility, one that exists in the realm of technology, not geology. Artificial illumination. A probe, powered by some long-lived energy source, perhaps coated in a thin layer of collected interstellar dust and ice as perfect camouflage. Its light isn't a reflection, it's a beacon we're only just learning to see. Loeb and the Legacy of Oumuamua. This isn't the first time we've had this conversation. In 2017, the object Oumuamua accelerated for no apparent reason, lacked a visible coma, and had a strange, elongated shape. Professor Avi Loeb of Harvard University famously suggested it could be artificial, a light sail, or a piece of alien technology. The scientific mainstream largely dismissed it. Now, with 3I/Atlas, the questions are returning, louder than ever. The ingredients are all here: the strange trajectory, the anomalous light, the perfect timing. Loeb and others argue we must stay open to the radical idea that the simplest explanation might not be a natural one. The universe is 13.8 billion years old. Another intelligence could have had a multi-billion-year head start. Sending autonomous, self-repairing probes to every star system in the galaxy isn't just science fiction. It's a plausible, even efficient strategy for exploration. 3I/Atlas fits the profile of a von Neumann probe, a self-replicating spacecraft designed to survey star systems for millennia. Weird, but not alien. Of course, the overwhelming majority of scientists urge extreme caution. The mantra is still extraordinary claims require extraordinary evidence. They offer natural explanations. Observational bias. Could it be that objects with these perfect orbits are simply easier for us to detect, making them seem more common than they are? Exotic chemistry. The unusual glow could be caused by a type of ice or volatile material we've never encountered before, reacting in unexpected ways to sunlight. Statistical fluke. A 1 in 20,000 chance is unlikely, but not impossible. Unlikely things happen in a universe full of objects. They argue that calling it alien is a surrender of scientific curiosity. The truth, they say, is probably even weirder than we can imagine. A new type of celestial object that will teach us entirely new physics. What it means for us. Whether it's a comet or a craft, 3I/Atlas is holding up a mirror to humanity. Our reaction to it reveals who we are. Are we a species that dismisses the anomalous? Or are we one that has the courage to ask, what if? This object is leaving. Soon it will be gone forever, a silent speck disappearing into the interstellar dark. We may never get a definitive answer, and perhaps that's the point. Its legacy won't be the data it provided, but the questions it forced us to ask. Are we alone? And if we're not, are we ready? This visitor, whether by design or accident, has become the ultimate test. Not of our technology, but of our imagination. This is the frontier, not just of space, but of thought. If you want to continue this search with us, to be here when the next anomaly arrives, subscribe and hit the like button. It truly helps us continue the mission. And if you want to go deeper, consider becoming a channel member. Your support helps us dedicate more time to investigations like this, to buy better data, and to ask the big questions without fear. Because the next time something comes visiting, we need to be ready, not just to see it, but to understand what it means. Thanks for watching.